Well, thank you for a wonderful introduction, and also, Doc, I really appreciate being here. It's really an honor for me to join the Founders Day celebration for this very important institution with a lot of experts in the textile industry listening. And I'm really very pleased to have the opportunity to share with you some information about our company and about our products. And also, I hope we'll have a good discussion after the remarks. We can talk about sustainability more generally or about our products. So without further ado, let me get started on the talk on the future of biomaterials. I first wanted to just quickly introduce our company. So again, as you've heard already, we were until last June 1st a business within the DuPont company. And in fact, I personally spent 34 years of my career in the DuPont company. And in that time when we were in DuPont was funding for us a lot of incredible groundbreaking research in how to make high performance chemicals and materials from plant-based resources. And starting on June 1st, we're now been acquired by a Chinese conglomerate called Huafeng Group. We're a US headquartered multinational company. We have about 220 employees around the world, including right where I'm sitting today in the wonderful offices and labs here in Gurgaon that we have in India. We're headquartered in the US. We have employees in 15 different countries, and operations, our manufacturing operations are based in the US. I personally started this journey way back as a PhD in material science and engineering. So I came to this area from the materials side of things. I've always been interested in new materials. And I had a lot of different jobs in DuPont in different businesses. But since about 2006, so 17 years ago, I've been leading this biomaterials business. And it's been a real pleasure for me and a real honor to be associated with this business. Okay, so I want to talk a little bit about our process. And you heard a little bit about this from Dr. Lal already. But I think what's unique is everyone in our industry is familiar with high performance chemicals. And typically, those high performance chemicals, I'm going to go off camera so we can get a little bit more. I don't know what happened to my charts. The charts went off the screen. Yeah, all right. Yeah. So we're familiar with these things being made from petro-based materials, and that's been a fabulous addition to the textile industry. Resume. However, if you look back in time, for thousands of years, human beings have been making chemicals by a more natural process called fermentation. And basically, fermentation is the use of microorganisms. Microorganisms eat sugar, and then they make in their inside of the microorganism a chemical. So the most well-known one, of course, is ethanol. So for thousands of years, human beings have made beer or wine or other kinds of things, or ethanol for fuel, by using a fermentation process. We use exactly the same process, but instead of making ethanol, we make a chemical called 1,3-propanediol that we call BioPDO. And again, the way that process works is it starts with corn sugar. So corn is harvested, it's processed, the starch fraction of the corn is taken. Today, that starch fraction becomes ethanol for fuel, or it becomes high fructose corn syrup sweetener. We take some of that same glucose from the starch and we ferment it into 1,3-propanediol. We then refine that material, and from that we get a very high purity, high performance chemical, BioPDO. I just want to mention quickly that there's a lot of discussion about, hey, why are we using food for the use for chemicals? And the reality is, as I mentioned, the starch fraction of corn is, at least in the United States, is primarily used first for ethanol, and secondly, for high fructose corn syrup. Both of these uses are declining. And so in fact, the rest of the corn, the oil, the protein, the fiber, is still used as it's always been to feed animals. So a lot of the corn is used to feed animals, a little bit is used to make starch, and that's the fraction that we use to make our BioPDO. Once we have that chemical BioPDO, we make a polymer called Sorona from it. So again, you can see here on this chart, the first steps here where the corn sugar is fed to a microorganism in a big tank. Fermentation happens, we refine the BioPDO. And as Dr. Lal mentioned, we reacted with another monomer, terephthalic acid, which I think most people are familiar with as a key component in PET and PBT polymers. And from that, we get a very high performance polymer called Sorona. We sell those pellets of Sirona out into the marketplace to people that make fibers for apparel, for carpet, and for other applications. So those are the really main commercial products of Covation Bio. I'll mention, and I'll come back to it again at the end, we also have other products in our pipeline. While we were with DuPont, we developed some other really great technology to make other important high-performance chemicals from plant-based resources. But the ones that are commercial today and have been commercial since 2006 are BioPDO and Sirona. So again, I mentioned this is not, we're not a startup company. We're a 16-year-old commercial company. We're about $250 million in sales around the world. So if you're thinking about using these materials, you don't have to worry that there's some kind of a startup process or they're not available. We have well over 100 kilotons of capacity of Sirona, about 77 kilotons of capacity of BioPDO. We're a commercial business, and these products have been proved out in the marketplace for the last 16 years. Okay, so let's talk about why should we be excited about Sirona? So what I do here is, again, remember, I'm a material scientist, right? I come from the point of view of a materials guy. So what we have here in this chart is just a comparison as a polymer of the polymer properties, not as a fiber or as a fabric, but of the polymer of Sirona versus PET, PBT, and nylon, three of the materials that are closest to us. And what you can see is Sirona has some very unique properties, and certainly a unique combination of properties. So particularly in softness, Sirona is a very, very soft material. It sometimes can feel like cotton or other very soft silk, other very soft kinds of fibers. If you compare that with other polyesters, PET or PBT, they're really okay, but they're not really soft. Nylon is a bit softer, but Sirona is even softer than nylon. Resiliency, which is particularly important in carpet applications, Sirona is significantly better than PET and PBT, and even better than nylon. If we look at stain resistance, all Sirona, PET, and PBT are all very, very good. So in the carpet market, they have a real advantage over nylon. And nylon is a material that requires stain-resistant coatings to be placed on the fiber for the material to be very stain-resistant as a carpet. Another important thing, and I know everybody on this call is very familiar with this, is the method of dyeing of a fiber or fabric is really important in terms of the carbon footprint of that fabric because it affects the energy usage. And again, nylon and Sirona use lower temperature dyeing. PET and PBT require higher temperature dyeing. In terms of elongation, another very unique aspect that we'll come back to with Sirona is that Sirona has natural elongation because of the polymer structure. And that allows us to have stretch and recovery. And I think everybody's aware, there's a huge movement in the marketplace. Everybody wants their fabrics, their garments to have stretch, to have comfort. And that Sirona has a built-in amount of elongation in the polymer. And then finally, in UV resistance, particularly for things like swimwear, PET, PBT, and Sirona are all quite good. It is better than nylon. So again, this is where we start with the polymer properties. And how does that translate into how it behaves in the real world? So when we talk about any kind of biosynthetic material or synthetic material like PET or nylon, typically we talk about filaments and we talk about staples. Staples typically used to be in combination with natural fibers. Filament is used for more synthetic kinds of fabric structures. And so when you look at our filament properties, we have some special properties such as warmth retention. We can make elastic filaments that can compete quite nicely with spandex like Lycra. We can make cool touch types. We can make moisture management kinds of fibers, and we can make Sea Island very super soft filaments. And in staple, typically what we're used for there is we have a warmth retention staple, and we have a very low temperature dyeing staple that can be used in combination with things like cotton and nylon. If we look on the sort of standard fibers, we have these functional fibers I've just talked about. And then we talked about standard fibers. For the filament type, we have really two flavors, right? You can spin just Sirona. We call that homogeneous Sirona. That's used very often in, for example, shape memory fabrics. A very, very interesting kind of fiber is if you spin Sirona and PET side by side, it naturally will crimp on itself and create sort of a natural spring. So when you want that stretch and recovery we were talking about earlier, if you use something like elastane, spandex, whatever you want to call it. That's more like a rubber band. That stretch comes from a chemical bond within the structure. And what happens is over time, if you wash that fabric a lot, or you wear the fabric a lot and stretch it a lot, eventually it loses its recovery of stretch. If you make a Sirona bicomponent fiber with the Sirona PET side by side, because it's a spring structure, the stretch and recovery are much better, particularly the recovery. On the staple side, it's the same thing. We have Sirona Homo Staple, which brings softness and a little bit of elasticity to those kind of natural yarns. But the bicomponent staple, again, short fiber staple, brings a really nice feeling of elasticity to spun yarns that have that very natural soft feeling. And then finally, we have what we call our Eco Plus fiber series. And here what we're doing is we're combining Sirona, which again, as we've already heard, is partially plant-based and therefore much more sustainable, with things like recycled PET, rPET. And so by doing that, we can create a fiber that's sustainable all around, not just the Sirona part, but also the rPET. We can also create other kinds of eco-friendly things like colored filaments and colored staples that require a lot less energy to dye. So again, if I know the people on this call are mainly textile people, so they're mostly going to be interested in where are you used. And I mentioned already, we've been commercial for 16 years. So we're not a startup. We're not beginning to figure out where to use this. We're used commercially all over the world. And here's some of the most famous or appropriate uses of Sirona. So things like yoga wear, where you want stretch and recovery and you also want softness. That great combination is something that comes from Sirona. Sportswear is another one. We're very much used by a lot of the world's best sportswear brands because of the combination of softness and performance. Shirting and bottoms, women's wear, suiting, all of these kinds of fabrics where you can use some of the properties that I've mentioned, whether it's stain resistance, whether it's a little bit of stretch or a lot of stretch, whether it's the softness, all of those things are used in these various different kinds of fabrics. Another one I haven't mentioned yet is insulation. So when you make those bicomponent staple kinds of fibers, again, they crimp and they ball up on themselves, and it makes a very, very effective insulation, as effective as some of the best synthetic products that are out there. We're also, another great application we have right now, which is beginning to really catch on, is faux fur. So I think many people are aware of consumers' preference now to get away from animal-based products. So some of the key designers in the world, like Stella McCartney, have already adopted Sirona-based faux fur. And that faux fur is made again with a Sirona Homo Staple. It's incredibly soft. Really, honestly, people can't tell the difference between it and the finest minks and the finest kind of fibers that are out there, natural furs that are out there. In that case, it's much more environmentally friendly. Obviously, it doesn't harm animals. And in some cases, it also brings better properties, better durability, for example. Finally, I'll call out footwear here, but there are, if you're familiar with a lot of the new kinds of sports shoes that are, for example, Flyknit on the top, a lot of those folks are using Sirona homofilament in the tops of those shoes because it brings a little bit of stretch, a lot of performance, and a lot of softness. So if you're out there and you're thinking about these kinds of applications and you're wondering whether Sirona might be useful for you, certainly the people sitting here in our office here in Gurgaon, we have a team of people here in India to cover the South Asia region. Please contact them, and they can give you more information on some of the applications where Sirona has been used. Okay, so I've talked a couple times about the facility here, and I don't want to spend a lot of time, but I just want to show you some pictures of where we're sitting. So we're very honored to have some guests here with us. You heard two of them speak already. Very honored to have them here. And what we have here is really a very functional lab, an office space to help support our customers here in South Asia. So you can see here pictures of some of the office spaces. You can see the textile manufacturing lab. There's a testing lab. There's a dyeing and finishing lab. So from start to finish, we can create spun yarns. We can create all kinds of different fabrics. We can dye them, and we can do all the kinds of testings that are required to help people develop their applications. So it's really a great facility and a great asset for our customers to have these kind of capabilities at their fingertips. And just, I won't read through these, but Dr. Akshay Kumar, who you heard briefly from earlier on, has worked with his team to set up a lot of different capabilities. And you can just take a quick look at this. all the different things that we can do here. And so it allows us to develop new yarns from staple. It allows us to develop new fabric constructions. It allows us to help our customers to tweak and better develop new fabrics that they need for their new collections. A lot of great stuff going on here. And of course, we can also test whatever we fabricate as well to make sure it meets all the relevant international standards. So I wanted to close by talking about some of the work that's already happened here, particularly in India. And I'm sitting here with two of our folks, Gary Nagarajan and Nilmani Ramakant, who have been very much involved with customers here, as well as getting great support from our technical team led by Akshay to drive some really important adoptions. You okay? Oh. Okay. Oops.
Could we go back and show the slides?
Yes. Okay. So sorry about that. I understand that somehow the charts weren't advancing. I don't know why. They're
What is still to present? We have done that. We have done.
okay.
No. See, at some point, someone else will control after.
Yeah, I don't. I'm just going to do this. I'm going to do it this way. Yeah, somebody did, and yeah. Okay, let me get caught up. This will be now. I'm okay. Now I know what I'm doing. Okay, so again, what I want to talk about a little bit is some of the real applications that have already happened here over the last 15 years or so here in India. So we broke these down into three different ones. One of them is Sirona in staple format, and so here what we're doing is we've worked with some of the strength of India is very strong in linen, as you guys know very well. So we've worked with the regional supply chain here to develop some fabrics, beautiful fabrics, where you combine linen, which I think everybody knows the uniqueness of linen, the hand feel of it, together with Sirona staple to make something that has even better properties. And that those yarns and fabrics have been adapted and sold throughout the world. JP Modatex is a very innovative yarn spinner. We took those Sirona linen yarns they were adopted at Levi's, Orvis, and Raymond. And we want to talk about the excellent company Wellspun has also found a unique value proposition where the shrinkage property of Sirona yarn brings some really interesting properties in terry towels and creates sort of very special, luxurious feeling kinds of towels. And so that's what we can do with some of our staple-based yarns. And again, India is well known around the world as a real center of textile innovation, particularly in sort of natural, heavy kinds of fibers and fabrics. And so here's some of the things we're doing in Sirona as a staple. We've talked about the Sirona filament already. Here we're typically talking about stretch. We mentioned Killer and Turtle here as a couple of important brands. We have identified these early adopters that are using it in both denim and shirting to bring stretch and softness. And we've also worked with a yarn dyed partner here, Wampum Syntex, to launch the dyed yarns that have been adopted at these brands, Killer and Turtle, to make some really beautiful and unique looking. I'm looking at Nilmani. He's wearing a shirt that's one of these fabrics, absolutely gorgeous, utilizing Sirona in the filament yarn format. And then finally, I think one of our most long-standing and successful collaborations here in India is with the wonderful sari company Lakshmapati. And over the years, they saw very early on, they're a very innovative company. They saw early on the value of Sirona in the sari market because sometimes it can feel like silk. It's certainly higher end than some of the other kinds of fabrics that are used for more budget kind of saris. It kind of fits in between silk and the sort of budget area. And that really soft touch was really the critical thing, as I think you guys know better than I do. In chiffon and georgette types of fabrics in particular, that hand feel, that really softness is really what the consumer is looking for. And so Lakshmapati, if you go to their website or go to their catalogs, there's lots of beautiful fabrics that are out there utilizing a local supply chain that use Sirona. And we're about to bring out some newer kind of higher end fabrics that combine silk with Sirona to get some very interesting properties there. So just to give you, this is certainly not all the activity that's happened or is happening right now in India. And also I would mention it's really all of South Asia, Bangladesh, Pakistan, and Sri Lanka. There's lots going on. This is just to give you some thinking, some ideas that might be useful. Okay, so I was asked, Akshay asked me particularly to talk a little bit about what's coming in the industry, particularly around sustainability. So on the industry trends, I think there's absolutely no doubt that there's all of a sudden sort of a huge demand from consumers for more sustainable solutions. So, as I said, I've been in this business now 17 years. We've been talking about this for a long time, but I used to always feel like the brands were talking about it, but they only wanted to appear that they were going to do something sustainable. They weren't really investing. But what's happening now is particularly the younger generation is demanding more sustainable solutions in everything, whether it's in food or the cars they drive or textiles, whatever it may be. And so what I see now is a very much stronger commitment to actually implement sustainable solutions, and it's coming very quickly. So I think the companies that are saying to themselves, well, I'll just wait and see, maybe I'll do sustainable, maybe I won't, I'll let somebody else do it, those companies will fall behind. They've done that for the last 5 years. It's been okay, but starting now and moving forward, I really do think the world's changing very quickly around sustainability. Another thing that's happening, particularly I think in the Western world, is that consumers are thinking very hard about how much they buy. And there's been this whole phenomenon of fast fashion where people would buy something, let's say a t-shirt, and wear it 2 or 3 times and throw it in the trash, which is incredibly wasteful. And I think people are reflecting on that and saying to themselves, you know what, I'd be better to buy fewer things, but things that I really like, that are designed beautifully, and also that will stay more durable. And again, for us in Sirona, that falls directly into what we talk about. Our Sirona may sometimes be a little bit more expensive, but for example, it'll stay softer longer. It'll stay stretch, and the stretch and recovery will last longer through more launderings. So for us, we're very much on board with that idea. And I do think that's something that in the industry is coming, where every company, I think that if they've been in a fast fashion game of making a lot of very cheap things as fast as they can, I think that game is changing. And then finally, I think what we're seeing, and some of this was accelerated quite a bit by the pandemic, is more and more people are not differentiating between their work clothes and their leisure clothes. And people want to have what they call athleisure or functional clothing. And what they mean by that is these are clothes that are very comfortable and functional, but yet also look good enough that I could wear them to work. And so I think we see it all around. People are changing the way they dress. And what that means is that, again, we talk about stretch. It used to be maybe I have a suit, and the suit is not that comfortable, but it looks good. And then I have clothes with stretch in them that I wear around the house or to do my exercising. Now people want everything in one garment. And I think that's something it's a long-term trend. It's been coming for a long time, but with the pandemic, where people were working a lot from their homes, more and more we really see that. So I think those are the brands that are growing the fastest. If you look at the brands around the world, who's growing the fastest? Most of them are in this game of athleisure. So there's some trends I wanted to share with you. Let me talk a little bit about what we see in our business. And again, we're a biomaterials company. There are other biomaterials companies too, but what we're doing and what we're coming up with is, first of all, we've almost exclusively for the last 16 years sold into the filament business. So the bicomponent fiber I talked to you about in stretch, the homo fiber that was sold into shape memory type fabrics, those have been the bulk of our volume. But what we're seeing now is a huge demand for spun yarns. And so, again, I think this plays very strongly to the strength in India. India is, I think, if not, I think it's, in my mind, it's the world leader in these kind of fibers and fabrics because of the strong tradition of cotton, of silk, of rayon, all that goes on here. So for us, we see a lot of growth there. And frankly, this year in our strategic plan, a huge focus has been placed on growing both bicomponent staple and homo staple into these kind of spun yarn applications. We've been, as I mentioned, in spandex replacement for a long time, but we're still less than 1% or something of the size of the spandex market. And again, because of the trends that on one hand, people want longer lasting stretch, it plays to Sirona bicomponent filament to replace spandex. The other big thing is when spandex is used in a garment, even at 2 to 5% loading level, it makes it so that garment is no longer easily recyclable. Sirona is recyclable. And so because of that, some brands are really driving away from spandex and towards products like Sirona for sustainability reasons. I've talked before about the core uses of Sorona in industrial applications. So these are products. Cysterea and Zimea are the brands of BioPDO that we sell. I haven't talked about them yet, but BioPDO by itself is a really wonderful chemical with a lot of interesting properties. And so what we're seeing, for example, in the polyurethane industry, whether it's polyurethanes for shoe soles or automotive applications, those customers also really want to have a much more sustainable bio-based product. And so our BioPDO under the brand Cysterea can be used in those applications and help them make their products more sustainable. And Zimea, which is the grade of BioPDO that's used in cosmetics and personal care, again, consumers are asking, I want something that's more natural. I don't want petroleum-based ingredients in my cosmetics or my hand cream or whatever. And we offer an opportunity to bring both more functionality and also a more natural plant-based solution to those applications. So that's sort of building on what we've done in the past. If we look forward, in the BioPDO space, we're beginning to see a lot of interest in using those materials in coatings like paints and other sorts of coatings, heat transfer fluids, and food and flavors. Those are segments that have been quite small for us in the past, but they're beginning to really accelerate. And again, some of these are very relevant for the markets here in South Asia. And then the other thing that I can't say too many details about, but what I will say is this, is that while we were in DuPont, I had an amazing research team, I still do. And they developed some incredible technology to make other molecules, not BioPDO, not Sorona, from plant-based resources. And if you follow the history of the DuPont company, you'll know that going back to about 2015, they changed strategies and they basically gotten out of the materials industries. And so because of that, I had technology, our business had technologies that were ready to be commercialized that DuPont put on the shelf. And our new owners are a $10 billion materials company. They have the cash and they have the desire and the will to invest in these things. So we are already, as we speak now, investing in building commercial plants for another kind of chemical. We're also building more capacity for Sorona in Asia. Those things are happening very quickly. So you'll see from us in Covation that we're going to expand the applications of the products we already have and also bring some more new high performance biomaterials to the market. So I think that's it. I would love it if people have questions. I would love to hear questions from the audience, and I'd love to have a discussion here about what's interesting to you about sustainability. So I'll stop sharing, and maybe I'll go on camera, and I'll be happy to take any questions from folks. Why don't we start here in the room? Are there questions here in the room?
First of all, I have a question from Dr. Moik. See, you said that you are able to get molecular elongation in the manufacturing stage, and because of that, stretchability is ensured. So how that is it in drying? You are maintaining drying, that means in a way that molecular elongation is too much. Is it that?
Yeah, well, it's got a combination of two different things. At molecular level, because the carbon, the PTT molecule, the Sorona molecule, has a 3-carbon glycol. So if you think about PET as a 2-carbon glycol, BBT is a 4-carbon glycol. When you have they have what's called the odd number effect. So when you have a 3-carbon glycol, it creates a kink in the structure just because of the natural way that the carbon molecules align themselves. So at a molecular level, it's inherent to the structure. By having a 3-carbon glycol, we get some stretch at a molecular level. And then I think what you're asking about is in our bicomponent fiber, you're exactly right. When you spin it,
This is what he's talking.
yeah, so you can, I'm sorry, we're showing a picture. So, the other way we get stretch is that at a macro level, when we spin those fibers, they crimp on themselves. And you're exactly right. The heat treatment has a lot to say about setting that crimp and making sure that it stays in the fiber. So there's two kinds of stretch mechanisms. One is at a molecular level, and the other is at more of a macro fiber level. Yeah.
Secondly, is it amorphous fiber? Because moisture management you are talking about, that moisture management may be due to the biocomponent. Because of that property of moisture regain and absorption may be coming.
Yeah. So because of the odd number effect that we just talked about, the Sorona does crystallize somewhat more slowly than PET or PBT, but the fibers are primarily crystalline. So the moisture management actually is mostly done through, number one, Sorona is a little bit more hydrophilic than other kinds of synthetics, but mostly it's through the actual shape of the fiber. by structuring them correctly, you create channels that wick the water away.
So it becomes amorphous, not rather than crystalline structure.
Well, the actual polymer itself is mostly crystalline, a little bit amorphous, but it's the structure of the fiber itself that actually creates the moisture management.
Then how it is biodegradable, you say?
It's not biodegradable. Yeah, so we're recyclable, we're bio-based, and we're recyclable, but we're not biodegradable.
Recycling.
Yes, sir. Yeah, Sorona can be recycled together with PET. So of course, PET is a huge recycling stream. We are tiny. So luckily, we have proven and we've been certified that you can mix Sorona in with the PET waste stream and recycle it together.
And the other product you are talking about that for industrial application, that is Jamia and
Sostera.
Sostera.
Yes, sir.
So these will be high performance fibers.
Well, they're not, in that case, it's just, yeah, these aren't fibers. Those are actually the chemical itself. So it's the monomer BioPDO that we use. Yeah.
So you are manipulating mostly monomers.
That's yeah.
Polymerization.
Yeah. So this chemical, so as an example, Sostera, when polyurethane guys use it, they maybe take out BDO, they replace it with Sostera, and then they get bio content and often some better properties as well. So you can think about PDO as a monomer. It's a building block. We use it to make Sorona. You can also use it to make polyurethanes or other kinds of polymers. And you can use it by itself in formulations like hand cream. And so it's used in all those different ways. So Zamea is for formulated products. Sostera is primarily for industrial products. And then Sorona is the polymer made from BioPDO.
Thank you.
Of course, my pleasure. Thank you for the questions. I see someone has raised their hand.
Yes,
Shailesh,
sir,
would you please go ahead?
excellent talk, Mr. Michael. I have a couple of questions. One was about morphology, which you have partially explained. That
Okay.
it's at molecular level by virtue of the different carbon glycols, etc. And the capillary action or the moisture absorbency is due to more at the macro level or the crimp structure. Am I correct, sir?
Yes, you got it exactly.
Okay. And what is the moisture regain vis-a-vis cotton, polyester, nylon of Sorona?
0.15, my guys are telling me.
Pardon, sir?
It's 0.15.
0.15.
He wishes to, he
It's lower than polyester.
Oh, okay, lower than polyester. Yeah, slightly lower than polyester. Yep.
Okay. And,
Similar, but a little lower. Yep.
okay. And if can I use it in short staple spinning?
Yeah, we are doing that, sir. It's already in commercial stage.
Yes.
Okay.
So
We
I
got
meant,
a product launch.
yeah, I mentioned some of the applications that we're doing. So people are doing, linen staple fiber, yarns. They're doing cotton staple, Sorona staple yarn. So, and again, we have the homogeneous homo staple, and we also have the bicomponent staple that brings a little stretch. The gentleman sitting next to me, Dr. Kumar, is actually I think the world's expert on the use of Sorona staple in yarn. So I would encourage you, if you're interested in that, to please speak with him.
Dr. Nandan, you mean to say? Yeah. And any major changes I have to make while spinning and process control and of Sorona staple?
Yeah, Ms. Shadichi, we can run it on the regular spinning system, but we have to have certain sequence to be changed and the certain parameters, especially in the carding, draw frame, speed frame has to be customized as per the Sorona usage. So that guidelines we usually supply to the customer whenever the trial runs with the customer, the Sorona based yarns. So we have a whole team hand holding right from staple spinning, fabric manufacturing, fabric dyeing and processing until they really realize the Sorona solution in the fabric.
Any 3 point which you highlight while in the chemical processing of Sorona dyeing printing?
It's like
any
the
special
dyeing temperature and heat setting temperature are like 15 to 20 degrees lower when you use Sorona. And then that is one thing. Then basically that is the key thing which we need to have for the Sorona fabric processing. And then you need to like, when you are getting stretch property, then a certain, segment like shirting and all or knitting, you need to gray heat set. Because if you put that in wet processing without doing that, you'll have wrinkles in the fabric and that will not remove. So the gray heat set and dyeing temperature and the finishing temperature, these are the three key things which you have to take into account while, you spin and, kind of process Rona based fabric.
Yeah, and again, what I would emphasize, I said earlier, is that um, these are issues that many people have already worked out at commercial scale. So we're not bringing out, if you haven't heard of Sirona before, it isn't a new material. We've been around a long time, and there's a lot of knowledge on exactly how to run on different kinds of machines under different circumstances. So again, if that's of interest to you, please contact Dr. Akshay here, and he and his team can help you to implement Sirona at your manufacturing facility.
And without compromising your intellectual property right, if you can elaborate a little bit about how this bicomponent fiber polymerization takes place. Well, how is it?
Yeah, no, it's no problem. It's been around a long time. Bicomponent fibers, like a lot of people know Lycra T400. Lycra T400 is Sirona bicomponent. That's just their brand name for it. So it's been around a very long time. It's basically, you have two extruders in the fiber spinning operation. And they have to run at different temperatures because the PET and the PTT melt at different temperatures. So you run them, the two different polymers through their separate extrusion lines. You bring them together at the spinneret, and at that one spinneret, you bring together the two different polymer streams and you spin them side by side. And then there's some tricks in terms of how you wind the fiber and all these kind of things, but these are all well established. And that's the way that bicomponent is formed. And so there are many suppliers around the world of Sirona bicomponent fiber. And in fact, we're actually very soon, can I talk about this? No. We're hoping very soon to have a supplier of Sirona bicomponent here in India. It's been a source of frustration for me personally because I know there's a huge market for Sirona bicomponent here in South Asia, and we haven't had it been made. It's all been imported from China or Turkey or some other place. But I think very soon you'll see a domestic supply coming of Sirona bicomponent fiber.
Sir, two very small questions. Any usage in medical textiles, which you have done till now?
Yeah, no, we've been used in masks and scrubs. And again, the real value proposition there is the comfort and the softness. Typically, these garments are not known for being necessarily breathable or comfortable to wear for the employees. And so one of the big focuses for us is the entire segment of what we call workwear. So uniforms and medical garments, this sort of thing, because again, we bring durability, we bring softness, we bring performance. And for a hospital or a train company that has uniforms for their employees, being able to use that garment over and over again, which we bring more durability, is a great value proposition. So actually, that's an area that's one of our best places, right? Yeah, what Gauri's telling me, again, if you think about it for uniforms, they face a very robust washing process, right? Industrial washing is very, very difficult for many fabrics to survive, and Sirona helps with. So again, for a lot of uniform producers or uniform users, Sirona is used already today. That's one of our big applications.
So, thank you, sir. One last question. It will be short and sweet. If I am a polyester yarn manufacturer, like a Filatex or Modern or Reliance, can I use your monomer to make this Sirona polymer?
No, so we sell the polymer, and so Reliance, I know them very well. That they certainly could use all their spinning operations to spin Sirona either by itself, which we call HOMO, or together with PET, which we call BICO or bicomponent. But right now the monomer isn't sold to be made into polymer. The polymer is actually sold.
Thank you, sir. Thanks a lot, and great hearing from you. Thanks a lot.
Thank you so much. Thank you for your questions. I see the next person up here is Mr. Kushi Gangwar. Please.
All sort of doing.
Okay. I'm sorry, I'm having trouble hearing you.
sir.
Yeah,
Yeah, it's audible now. Please go ahead.
please go ahead.
So, good afternoon, sir. I wanted to ask that I'm a UG student doing textile engineering course. So I just wanted to ask that.
Kushi, better if you type down your question.
Yeah. Yeah, Kushi, maybe can you type your question into the chat and I'll take a look at it there? And I can try to answer because we can't really hear you.
Yes, sir, I will be typing. Thank you so much, sir.
Okay, thank you. Okay. So while we're waiting for that question to come in, Ajay Tyagi, do you have a question I can answer?
Am I audible, sir?
Yes, you sound fine. Thank you.
It was a great hearing you, Michael. It was a wonderful presentation. Just my small question is, your title is biomaterial, and you just mentioned in your presentation that you prepared this propane diol and polymerized with terephthalic acid. So terephthalic acid, I think you might have taken from petroleum route. So how you can claim it biomaterial? Is it
Yeah, no,
50%?
yeah, it's a great question. So I think what people are looking at in the world of sustainability right now is we need to make positive steps. And there's an old saying that you don't want to let the perfect be the enemy of the good. And so you're exactly right. The bio content of the Sorona polymer today is 37%, not 100%, and by weight. And so we're trying very hard to find bio-based or plant-based routes to TPA or even recycled routes. If we could get recycled TPA from chemical recycling, we would use that as a more sustainable option. But it's certainly true that the Sorona polymer is 37% bio-based. 37% is a lot better than 0%. And that's the way that we look at it. That's the way that our customers look at it. BioPDO, of course, is 100% bio-based. And that's our ambition is for all of our products to be 100% bio-based. But we feel like we need to help the world make steps in the right direction, even if they're not complete steps, to get us from where we are now, which is completely dependent on fossil-based materials, to a world where we're not anymore. But it's a great question because it's exactly what people ask us all the time.
Thank you very much for being so honest and clear, transparent. Thank you.
My pleasure. My pleasure. So I see the question. I think the chat came in. Let me see if I can look at the chat here. Oh, okay. Oh, I see. Somebody asked a question. Let me go to these questions here. Somebody asked. Oh, there's a number of questions. Here we go. Wow, look at all these. Okay. The moisture content of Sorona, it's quite low. It's very, typically when.
1/4.
Yeah, 1/4 of polyester.
That we include in
Yeah, less than 1/4. Okay. Then does Sorona have additional properties like antibacterial? It doesn't have antibacterial by itself. What we can do, for example, is we have functional fibers like Warm Touch and Cool Touch, where you can add, you can put additives into the fiber itself that bring some additional properties. So Warm Touch and Cool Touch are two of the ones we have today. Right now, we don't have an antibacterial product available at the moment. Let's see. Any plan to develop FR option as well? Yeah, so we have in some applications, we are limited by FR at the moment, particularly in, for example, commercial carpet is an area that we like to be in. At this moment, I can't say anything about flame retardants, but in the future, that may be something we work on. And then how Sorona bicomponent filament can be more price competitive. The main thing for India is local supply, because the problem has been so far, the duties on bringing fiber in, particularly from a place like China or even Turkey, are so high that by the time a textile manufacturer in India tries to use bicomponent, they're priced out of the market, especially compared to their competitors in other countries that don't have these duties. So that's the big area that we're working on, is to develop local supply of bicomponent, and that'll make a huge, huge impact on the cost competitiveness. Okay, let's see what else we got here. Who is going to set up? Oh, that's a great question. I can't tell you. I would like to tell you, but I can't. You'll hear announcements from us quite soon about that. Do you see air lay technology being used in biomaterials? The answer is, nonwovens is an area that I think we have a lot of opportunities to get into. Obviously, today people use cellulose-based products. They're bio-based. So that a lot of the air laid markets are using that. But I think a product like Sirona with its special properties has a huge opportunity in all kinds of nonwovens, air laid being one of them. So I think that's a great question, and I do see a lot of opportunity there. And we're beginning to develop those, by the way. So if you have interest in looking at Sirona in nonwovens, please let us know, because we're actively putting resources on developing those applications. Is any insulation being developed from bio-based material? Well, again, Sirona insulation exists today. Very high performance. It's typically sold more on being high performance than it is being bio-based, but being bio-based is also a nice advantage. But if you're interested in buying those products, again, get in contact with the team here. Say again? Oh yeah, the Clo value, absolutely. Much higher performance than some of the other products. So that's a great thing. Wow, I got a lot of questions in the chat. Okay. And I'm a UG student and want to pursue my higher studies in composites and polymer field. How can I go for it? Well, I'm a huge booster of technical people that want to get into this field. So it'd be better to have a conversation than talk about it here. But I really do think if you're coming out right now, when I came out as a material scientist in the late 80s, it's a long time ago, the big thing then was semiconductors, right? And so if you wanted to get a good job, you really needed to work in semiconductors. Today, I really think biomaterials is one of the big fields. And so I would strongly encourage you, if you're interested in polymers and composites, to focus on the more sustainable products, particularly the bio-based products, because that's where the growth is going to come. So that's one piece of advice I can give you. So good luck to you, and I hope you have a great career. What are the common deniers of Sirona filaments, and what are the elongations? Sir?
300, 30 denier, 300. We have applied.
All right, our standard answer is 30 denier, 300.
Number of filament, where is the secret 12 to 30 denier, 12
Every
to
day
14.
it's like come with course, very course.
Very.
Oh, fine.
No, number of
Sorry.
Yeah.
DPF is around 2, we usually keep in the. 5 is 1.5. 1.5 for cotton spinning, 2.5 for wool spin.
The hot and cool touch technology, is it micro encapsulation technology? I don't think
It's
so.
additive based.
It's just an additive that they put in the polymer that brings that surface cooling. And again, if you're interested in that, that's a commercial product. So if you're interested in those kinds of fibers, please let us know. And then we are not compostable. The question is, are we compostable? The answer is no. We are in many ways very similar in terms of our end of life to PET. We can be recycled with PET, but we're not biodegradable or compostable. Okay, I think we got through the chat. Let's go. Let's see if anybody else has raised their hand.
Dr. Ajay wants to.
Okay, Dr. J, please go ahead. Ajay Tyagi, if you have a question or comment, please let us know.
No, Dr. Saab, already I have discussed.
Oh, you did
that-
yours.
that-
Okay, you're good.
It
Okay,
was done.
fantastic.
Thank
Fantastic.
you.
I see that.
Thank you. Sir.
Oh, my pleasure. It looks like then Sahil Sharma. Do you have a
Hi,
question or
Michael.
comment?
How are you? First of all,
Very well, thank
And,
you.
We are using Sirona for quite a few time, and it's been long that we are using. My question is, a lot of elevated products have been in market, like a lot of graphene induced fibers are there for the antimicrobial, or with the QMax value for the cooling around 160 and 180 also we have in the market. Is there any product from the Sirona itself or from you guys is in the pipeline for these kind of products?
Yes, so on Warm Touch and Cool Touch, through some of our customers, those fibers are available. Antimicrobial in China, those guys are looking at it at the moment. I don't know if that technology will be exportable or not, but certainly I would encourage you keep in touch with Mr. Gary Nagarajan here. He can keep you up to speed on what's happening internationally in our developments. But Warm Touch and Cool Touch, if they're of interest to you right now, we can tell you where to buy the fibers. Again, the problem is in India, with all the duties, by the time you import them, they're a bit expensive. But if you have the right customer, it could be a good opportunity for you. And again, I also want to say thank you very much for your
I'm
business.
already using. Warm Touch
Okay.
I'm already using. I'm buying from Taiwan right now.
Okay, good.
So the question is there anything you are working on antimicrobial right now? Because we are getting a lot of outdoor brands requirement around antimicrobials, which are lifelong, and we don't want to go into your silver-based products or anything. Better to go into fiber induced or bio-based products. So that's why I'm asking this question.
Yeah, sure. And so first, I want to say thank you very much for your business over the years. We really appreciate it. And then we are working on that. So right now, most of the development's happening in our China lab. One of the things, I think you know this very well, it sounds like you're very an expert in this area. We have to be very careful with antimicrobial claims because we don't want to say something to the consumer that isn't true about antimicrobial. And in the past, a lot of companies in many fields, not just textiles, have made claims about antimicrobial or anti-odor or anti-this, anti-that, that turned out to not be credible and they couldn't be backed by data. So I'll be honest with you that it's taking us some time to make this development because we will never come out with something that we can't back up with a lot of scientific data. So we are working on it. You should certainly stay in touch with Gallery about where we are on it. I don't have anything right now or in the next 6 months that will be commercial, but we are working on it.
Yeah, that's great to hear that you're working on.
That additive base we already tried, but not at the mobile.
Disponibility will be affected.
We have something in domain already in China, but with this product stewardship and all that regulation, we have really clear.
Yeah, that's the other thing. If you're a sustainable product, we have to be very careful. We don't do something that's
Same, it has to be perfect.
yeah, and
Go with the regulatory policy of the company.
yeah. We tend to be maybe sometimes a little bit slower than others, but that's because we want to be very, very careful.
Thank you, Mr. Doctor.
Oh, it's my pleasure. Thanks for the question.
Are these
Please on the line. Please hold on. I'm sorry. What was the question?
The question, what is the tenacity and other tensile properties we want to comment?
Oh, okay. Sure. Do you want to comment on
Yes,
tenacity?
it varies from 3.3 GPD to 3.8, depending on what form of fiber you are using. For homo, it is around 3.3 to 3.5, and for the bike, it is 3.5 to 3.8. And the elongation somewhere ranges around 30% to 50%, 30% for the homo and the 50% for the bike.
And how about your TG?
TG for the 100% homo, polymer based yarn, it is around 43 to 48 basically. 48 degrees centigrade.
For 25 lower than.
Much lower than.
Yeah, much lower than
40.
polyester for sure.
That's how this wrinkle recovery and that sort of thing come. Yeah, this can be done with the dispersed dyeing. So wherever you want to disperse dyeing, you can.
Once you are doing your polyester blend, what temperature?
Start from it's like
Dyeing is a one question, because that's.
that is where.
Talking about cadence section.
Yeah, that you have to be careful because you cannot go beyond 150. That is the maximum temperature we are seeing. And pasting also you have to be careful. Like 160, 170, you cannot go. Yeah, so that has to be.
But here, high temperature ironing may not be required.
No. 1 dot or maximum 2 dot we can.
Comes when we give the care instructions. What should be the care instructions?
Yeah.
In the blending. Here it has got shape memory type. No?
Yeah, 100% fabric.
Shape means I'm putting my understanding on the table in this format. Shape is because of the structure.
Yes.
The more number of carbon structure, because they're making more spirals. I shouldn't spiral, but making more.
Pinky type of W.
Crimp, yeah.
So it's more of a spring structure. That's what is improving its absorption as well, because that's creating more
Channels.
into it or space into it. And the fibers can suck in water or any liquid into it. And the third part of it, because the question was now, it comes back to the question of denier. I was talking about fiber denier. 4 say equivalent to 20s count or 40s count yarn. I'm talking about 14 count. 14 count.
how many number of fibers will be there in that structure? So that's a very technical question. We should
Yeah, so
have an answer.
yeah.
Yeah.
So basically, there's fiber yarn denier divided by fiber denier. The number of fibers will be same, but the diameter may be more. But
Exactly, I was gonna tell
yeah,
you
so the
next
bulk is more bulkier and thicker
There you go.
than the normal polyester fiber.
Yeah, it can have two impacts. It
Yeah,
can have two
and
impacts.
for softness also, like 1.5
Exactly.
denier polyester. I mean 1.5 denier. So now it feels like 1 denier, polyester.
Yeah, because it
More voluminous and
when it comes to the warmth properties or the cool properties. It's
application.
Can do later because participants.
Okay, sorry.
sure.
Yeah, well, he's tech. I love technical guys. Yeah, no worries, no worries. Was online, was there any other questions online? That people, I thought somebody might have wanted to ask one. Check the chat. Yeah, I checked the chat earlier. It was all okay. Ah, here we go. If we can share a link here through NIST where we can study the technical data. So I'll leave that for you, okay? Yeah, so Dr. Kumar will work for that. Thank you. Okay, are there any other questions that we can answer while we're together here? Well, if not, it was a great pleasure for me again. Thank you so much for giving me this forum to talk about the product that I think you can feel our whole team is very passionate about. I really do believe that we're just now at the beginning of when this product is going to be very successful here in India, because I think we're going to begin to overcome some of these structural issues in the supply chain that have held us back. There's plenty of market and there's plenty of demand, both for export and for domestic use here in India. So I'm excited about the future here, and I look forward to coming back and meeting with you guys again. Thank you again for your attention and for this opportunity to speak with this group. Thank you.
Thank you.